All right, let's do more practice using undetermined coefficients. And this time, let's find a general solution. So find a general solution of x prime equals ax plus f, where A is the matrix 2 minus 1, 3 minus 2, and f is the inhomogeneous term e to the 2t and e to the 2t plus 4e to the 3t. So in this case, just as usual, you first find the homogeneous solution. So homogeneous solution. Which just means to solve x prime equals ax. So solve x prime equals ax, again, where a is 2 minus 1, 3 minus 2. And this is as usual, you find the eigenvalues and eigenvectors. So this, for the details, you can check the notes if you'd like. So the eigenvalues are lambda equals 1 and lambda equals minus 1. And then for the eigenvectors, so for lambda equals 1, I believe an eigenvector is 1, 1. And for lambda equals minus 1, an eigenvector is 1, 3. And so what is the homogeneous solution? So we write it as x naught. It's just as usual, C1 e to the first eigenvalue t. So C1 e to the t times eigenvector, and C2 e to the minus t times second eigenvector. So that's as usual. And now let's find a particular solution. Particular solution. And I would like to remind you, so the f term, f of t, is, I believe, e to the 2t, and then e to the 2t plus 4e to the 3t, which you'll see in a second why we do this, but it's important to split it up into exponential terms. So e to the 2t times 1, 1, plus e to the 3t times 0, 4, I believe. And first of all, let's check for resonance. So here, the right-hand side, there are actually two terms, e to the 2t and e to the 3t. They correspond to eigenvalues 2 and 3, which fortunately do not coincide with the eigenvectors. Otherwise, you would have to do resonance on whichever term coincides. So it doesn't coincide with lambda is plus or minus 1, so no resonance. And so meaning that you just guess the solution the usual way. So here, xp of t. Let's see what we would guess. So usually you would do a e to the 2t plus b e to the 3t, except now a and b become vectors. So this becomes e to the 2t times ab, and then plus e to the 3t times cd, which if we want is a e to the 2t, plus c e to the 3t, and then b e to the 2t plus d e to the 3t. And now plug it in as usual. And so we have xp prime of t is a xp of t plus f of t. Oh, I remember Windows XP. Those were the times. Okay, so xp prime, that's the derivative of this. So ae to the 2t plus b, oh no, plus ce to the 3t. 3t prime, and then be to the 2t. E to the 2t plus d e to the 3t prime equals a plus f. So a, I believe, is 2 minus 1, and then 3 minus 2 times this whole term. So ae to the 2t plus ce to the 3t, be to the 2t plus de to the 3t plus your inhomogeneous term. Let's see, maybe here plug in. Plus your f term, which was just e to the 2t, and e to the 2t plus 4e to the 3t. And yeah, it looks quite horrible, but you'll see a couple of things will simplify very soon. So the derivative is just 2a e to the 2t plus 3c e to the 3t, and then 2b e to the 2t plus 3d e to the 3t. And then do the matrix multiplication. So 2a e to the 2t plus 2c e to the 3t. That's this 2. And then we have this minus 1. So minus b e to the 2t minus d e to the 3t. And same thing with 3 and minus 2. So 3a e to the 2t plus 3c e to the 3t minus 2b e to the 2t minus 2d, not 20, but 2d, e to the 3t, and then plus the inhomogeneous term, so e to the 2t and e to the 2t plus 4e to the 3t. So that whole thing is in one line. And as horrible as it looks, we can actually group a lot of terms. So if you want in terms of equations, that gives you 2a e to the 2t plus 3c e to the 3t. And now let's write this in terms of e to the 2t and e to the 3t. So 2a minus b plus 1 e to the 2t, the one from the inhomogeneous term, and then plus, I believe, 2c minus d e to the 3t, and then 2b e to the 2t plus 3d e to the 3t equals, so 3a minus 2b and then plus 1 from the inhomogeneous term, and 3c minus 2d plus 4 from the inhomogeneous term. And again, you're like, oh my God, this is getting different. The nice thing is now you can just compare both sides. So if you look at the e to the 2t terms, turns out you get two different equations. Or I want to say a system of two equations. So in this case, 2a equals 2b equals 2a minus b plus 1, and 2b equals 3a minus 2b plus 1, which is not the worst system, So the two A's cancel out, and basically you get B equals 1. And then I think you can just solve for A being 1. So then A equals 1 and B equals 1. And same spiel for the e to the 3t terms. Again, which is reassuring because you would expect a 4x4 system, but luckily not in this case. But if you're curious, there's an extra example in the notes where you actually might have to solve the whole thing. But here you just get 3c is 2c minus d, and then 3d is 3c minus 2d plus 4. And essentially you get, I think, c equals minus d, and you can solve this, and eventually you get c is minus 1/2 and d equals 1/2. So what does that tell you about your particular solution? So xp of t was e to the 2t times ab, so 1, 1, plus e to the 3t times cd, so minus 1/2 and 1/2. 1/2. So that was the particular solution, and just as before, the same fact is true for the general solution, namely that the general solution x of t is the homogeneous plus the particular solution. So in other words, what we have xp of t, x of t is, I think it was c1 e to the t times 1, 1 plus c2 e to the minus t times 1, 3. Was it 1, 3? Yeah, 1, 3, and then plus the particular solution e to the 2t times 1, 1 plus e to the 3t times minus 1/2 and then 1/2. Ta-da! And that's all she wrote. So once again, the homogeneous solution, use eigenvalues, eigenvectors for that, and for particular solution, you guess it based on the right-hand side.